Hello everyone, welcome back to my channel. So in today's tutorial, I'm going to discuss about MOSFET, construction and working principle of enhancement type MOSFET. We know BJT and FET both are three-terminal device, but the main difference between BJT and FET is BJT is a current control device, but FETs are voltage control device. So FETs are mainly JFET, junction field effect transistor, and MOSFET, metal insulator semiconductor field effect transistor. If the insulator of the MOSFET is oxide, then it is called MOSFET, metal oxide semiconductor field effect transistor. Like other FETs, MOSFETs are unipolar, majority carrier, and voltage control device, controlled by the voltage at the third terminal. Since the control voltage is applied at the insulator, the input impedance is very high and there is a small amount of current flow. So, they are well suited for switches, digital circuits, and IC. MOSFET is an active device, that means it can control the flow of electron as well current, as we know that the direction of current flow is opposite to the direction of electron flow. MOSFETs are of two types: enhancement type, where the channel is not formed at the beginning. It is of two types, N channel and P channel. Another one is depletion type, where the channel is formed from the beginning. It is also of N channel and P channel. Enhancement type MOSFET. There are mainly three terminals: source, drain, and gate. So this is an enhancement type MOSFET. This is the source terminal, drain, and gate terminal. There is also body or substrate on which the three terminals are situated. This is the body. As the source and the body is shorted, it is not considered as an individual terminal. The source and the body will be shorted. If the source and a drain are made of N-type material, then the body will be of P-type and the channel will be of N-type. But if the source and drain are made of P-type material, then the body will be of N-type and the channel will be of P-type. Now for this MOSFET, the body is of P-type material, the source and the drain are of N-type material. There are two PN junctions and so two depletion regions. Now, the gate is over a thin layer of silicon dioxide, that is called gate oxide. This is the gate terminal, that is over a thin layer of silicon dioxide. Its approximate width is 1000 angstrom. There is metal contacts over each, like the source, drain, body, and gate. So there is body that is made of semiconductor, over which there is oxide insulator, and over this there is metal. For this it is called metal oxide semiconductor or MOSFET. So here it is metal, then there is oxide, then there is semiconductor. So metal oxide semiconductor. After that, how the channel is made in enhancement type MOSFET. As there is no connection between the drain and source, there is no current flow at the beginning. So if we can make a channel between the source and the drain, then there will be a current flow. Here, the gate is the controlling terminal which controls the current by controlling the input voltage. For N-channel enhancement type MOSFET, at first apply positive voltage at the gate terminal by a battery. So at first we have to apply positive voltage VGS. So negative ions acceptor Na will be induced below the silicon layer and a thin depletion region will be formed between the source and the drain. But the channel will not be formed as the acceptors are immobile ions and hence no current will flow. But if we increase the voltage more, then electrons will come from the battery and a virtual N channel will be formed. Now, if we apply a positive voltage from the drain to the source VDS, electrons will flow from the source to drain and current will flow from the drain to source as the direction of the current flow is opposite to the electron flow. If there is no VDS, then only the channel will be formed and no current will flow. So at first we have to apply VGS, then immobile acceptor ions will be induced below the silicon dioxide and a depletion layer will be formed. If we increase VGS more, then electrons will come from the battery and a channel will be formed. After that, if we apply positive VDS, then electrons will start to flow and current will flow. So the positive charge in the gate must be equal to the amount of the charge in the channel. For that, the voltage at the gate must be larger than a particular voltage called threshold voltage. So if we apply VGS greater than the threshold voltage VT, then only the current will start to flow. So as the gate voltage controls the current flow, one view of MOSFET is that it is called voltage control potential barrier. Now there are three figures. First one is N-channel enhancement mode MOSFET. Next one, application of positive voltage and formation of depletion region by immobile acceptors. This is the depletion region formed by immobile acceptors. After that, formation of N-channel by the electrons coming from the battery. After apply more VGS. This is the N-channel. Now, negative charge in the N-channel is due to two reasons in the N-channel enhancement type MOSFET. Negative charge from the battery and from the immobile acceptor ions. If the gate voltage is greater than threshold voltage, then current will start to flow. This process is known as inversion. This is a normally off device as the channel is not formed from the very beginning and no current flows at the beginning. Later, after applying voltage, channel is formed and current flows and it becomes on. So it is called normally off device. For p-channel enhancement type MOSFET, apply negative voltage at the gate terminal by a battery. This is opposite to the n-channel enhancement mode MOSFET. So we will have negative VGS. Then positive ions, donor ions will be induced below the silicon layer. So donor ions will be induced below this silicon layer. And then a depletion region will be formed between the source and drain. If we decrease voltage more, then holes will come from the battery and a virtual P channel will be formed. If we decrease VGS more, then a virtual P channel will be formed. Now, if we apply a negative voltage from the drain to source VDS, holes will flow from the source to drain and current will flow from the source to drain as the direction of the current flow is equal to the hole flow. For p-channel MOSFET, the voltage at the gate must be smaller than a particular voltage called threshold voltage VT. If the gate voltage is more negative than threshold voltage, then current will start to flow. Now, this will act as a capacitor because for an n-channel enhancement type MOSFET, the gate is positively charged. After that, there is silicon dioxide that will be acting as a dielectric. And after that, there is a channel below that is negatively charged. So, like a capacitor, here it is positively charged gate, then dielectric silicon dioxide. After that, there is negatively charged channel. So, it is acting as a capacitor. Why the body and source is shorted? Because if the source and body are shorted, no current will flow from the source to body and the whole current will be flow from the drain to source for an n-channel MOSFET. That's why the body and source is shorted. So thank you so much for watching my video. If you like my video, then please press the like button and subscribe my channel. Thank you very much.